Dancing humanoids. Stop. I need you to pause that thought about the latest smartphone and look at this. This is not highly edited CGI. This is not a choreographed movie sequence. This is the new, terrifying, and incredible reality of bipedal robotics. We are watching a machine that has mastered an art form that takes humans years to perfect. The dancing robot is not just a party trick. It is the definitive engineering challenge, the Turing test for movement. It proves total mastery over bipedal dynamics, high-speed motor control, and real-time environment interaction. It means the hardware is, finally, ready. In this 10-minute tech update, we'll break down the engineering miracle that makes this movement possible, then dive deep into the national strategy in China that is poised to mass-produce humanoids globally, and finally, look at the worldwide future when millions of these bots leave the dance floor and enter our lives. Let's go. The big idea, A. Dancing robot is not just a party trick. It's the Turing test for movement. It proves mastery over dynamic stability, complex motor control, and real-time environment interaction. It means the hardware is ready. Roadmap. We're going to break down the engineering miracle that makes this possible, then do a deep dive into the national strategy in China that is poised to mass-produce humanoids globally, and finally, look at the worldwide future when millions of these bots leave the dance floor and enter our lives. Part 1. The Engineering Masterclass. The actuators. The secret isn't the CPU, it's the muscles. Explain torque dense. Actuators. Small, powerful electric motors capable of delivering immense, precise force instantly. They are the difference between a jerky industrial robot and a fluid dancer. Dynamic stability. Focus on the balancing act. The robot is constantly falling, catching itself. Discuss the role of IMUs, inertial measurement units, and model. Reductive control, MPC. Algorithms that predict the next few steps of movement, thousands of times per second to ensure the robot never fully loses balance, even during a jump. Why dance matters. Dance is a complex test environment. It involves rapid changes in the center of gravity and high-velocity limb movements. If a robot can execute a perfect plie and recover from a near fall, it can certainly walk on a factory floor littered with debris or carry an item up uneven stairs. Dance proves the readiness of the tech for the real world. Part 2. China's Humanoid Blueprint. Deep dive. Policy and scale. China's strategy is not about science, it's about scale and industrial dominance. They have national and provincial policies that prioritize the development of the humanoid robot industry. The goal is not a single flagship model, but rapid cost reduction and mass production to integrate humanoids into their industrial base first, and then the world's key players and prototypes. Mention domestic players like Unitree Robotics, known for their Unitree H1, and Xiaomi Cyber One. Crucially, highlight their focus on modular, standardized components. Unlike other programs that develop proprietary systems, these companies are building a manufacturing ecosystem where parts are interchangeable and easily scalable. The China advantage. Cost. This is the core of the global shift. China leverages its existing high-volume supply chains for motors, batteries, and sensors, enabling them to produce humanoids at a fraction of the cost of Western prototypes. This rapid manufacturing efficiency makes the humanoids everywhere vision economically viable much sooner, transforming the machine from a lab curiosity into a utility. Part 3. The global race to the factory floor. The Western approach. Contrast. Briefly compare the Chinese model with others. Other manufacturers focus on extreme, bleeding-edge capability and research. The primary focus for the Chinese industry, however, is on immediate, profitable deployment in areas where labor is physically taxing or repetitive. The humanoid job market. The proliferation of humanoids worldwide will begin in 3 sectors. 1. Logistics and warehousing, handling packages, sorting inventory. 2. Manufacturing, simple assembly, quality control checks. 3. Home and service, basic cleaning, assistance. The low-cost, high-volume approach means that for the first time, the CapEx cost of the robot is less than the OpEx cost of a human worker over a 2 to 3 year period. The data loop. As these humanoids are deployed worldwide, a massive, accelerating feedback loop begins. Every successful pick-and-place operation, every avoided obstacle, and every successful interaction becomes training data. The more humanoids that are working, the smarter the next generation of humanoids becomes, accelerating the development cycle globally. This mass deployment creates an enormous and potentially dominant data advantage. Conclusion: beyond the dance floor, we are at the dawn of the general-purpose humanoid. The demonstration of complex dance has proven the physics are solved. The low-cost mass production model pioneered in China is poised to democratize this technology, moving it from the academic lab to the global factory floor. Final thought: the dancing robot is not the destination. It is the most beautiful, compelling commercial for the most advanced, mass-producible hardware on the planet. The age of ubiquitous humanoids is here, and it will change our world faster than anyone expects. The dancing robot you saw at the start, it is not the destination. It is the most beautiful, compelling commercial for the most advanced, mass-producible hardware on the planet. This fundamental shift in manufacturing capability will reshape global logistics, industry, and the labor market. The age of the ubiquitous humanoid is here, and it will change our world faster than anyone expects. That's it for this week's 10-Minute Tech Update. Hit that like button, subscribe if you haven't, and let me know in the comments. What job do you think a dancing robot should take first? We'll see you next time.